Hi to everyone. MAMSE School of Engineering, Department of Mechanical Engineering, subject Mechatronics, Unit 1, Chapter number 3. Myself, S. Sarunan, Assistant Professor, Mechatronics Department. So this is the course objective and outcome of Mechatronics. Syllabus, textbooks and reference followed. The textbook and reference book for Mechatronics. Next, this is the Unit 1. So today we are going to see about chapter number 3, that is sensors and transducers. So in sensor and transducer we are going to see about static and dynamic characteristics of sensor. That means what is sensor, so what is transducer, then so what are the characteristics available in sensors. Okay, sensors and transducer. So measurement is an important subsystem of a mechatronic system. Its main function is to collect the information on system status and to feed it to the microprocessor for controlling the whole system. Okay, that is, sensor is in manufacturing are basically employed to automatically carry out the production operation as well as process monitoring activities. Sensor technology has the following important advantages in transforming the conventional manufacturing unit into modern one. Sensors alarm the system operates about the failure of any of these subunits of manufacturing systems. It helps operates to reduce the downtime of complete manufacturing system by carrying out the preventive measures. So reduces requirements of skilled and experienced laborers. So ultra precision in the quality can be achieved. Product quality can be achieved. So sensors, according to the Instrument Society of America, sensor can be defined as a device which provides a usable output in response to a specified measurement. Okay, here the output is usually an electrical quantity and measured in the physical quantity, that is property or condition which have to be measured. So then transistor, so it is defined as an element which subjected to some physical changes experience a related change or an element which converts a specified measurement into a usable output by using a transduction principle. It can also be defined as a device that converts a signal from one form of energy to another form. Okay, specification. So static and dynamic specifications. So first one is range. The range of the sensor indicates the limit between which the input can vary. Okay, for example, thermocouple for the measurement of temperature might have a range of 25 to 225 degrees Celsius. That means we need to define a sensor ranges. Okay, so that means if example, uh, if we want to measure some displacement means, so how much displacement distance will be that sensor will calculate or identify or recognize, like that we need to define. So first specification is range. So range of the sensor must to be defined. So next one, span. The span is the difference between the maximum and the minimum value of the input. Okay, so thus the above mentioned thermocouple will have the span of 200 because lower value will be 25, so higher value will be 25. That is maximum minus difference, that is minimum value. So the span of thermocouple is 200 degrees Celsius. This is a span. Okay, next one, error. So error is the difference between the result of measurement and the true value of the quantity being measured. Okay, a sensor might give a displacement reading of 29.8 millimeter. So when the actual displacement has been 30 millimeter, then the error is 0.2 minus 0.2 millimeter. So this is the error. That is actual value minus displacement reading. Actual minus reading value. Okay, that is error. So accuracy. So accuracy defines the closeness of the agreement between actual measurement result and a true value of the measured. It is often expressed as a percentage of the full range output full scale deflection. You can see in register they put a 0.01 percentage like that they are using. For example, 4 kilo ohm means they are putting 4 kilo ohm plus or minus 1 percentage like that. So that is accuracy ranges. Maybe it will be 1 percentage extra or 1 percentage is reduced. Okay, that is the accuracy of the sensor. We need to define accuracy of the particular sensor. Okay. So another characteristic is sensitivity. So sensitivity of a sensor defined as the ratio of change in the output value. Ratio of changing in the output value of a sensor to the per unit change. Output value of sensor to the per unit change in input value that causes the output change. For example, general purpose thermocouple may have a sensitivity of 41 microvolt per degree Celsius. That means per degree Celsius, how much voltage will be varying, like that they are defining. So that means for 1 degree changes, output will be 41 microvolt it will be changed. That is sensitivity. Okay. Next one, non-linearity. The non-linearity indicates the maximum deviation of the actual measured curve of a sensor from the ideal curve. Okay, in this curve, you know, this is the ideal curve, this is a measured curve. This is the non-linearity of the sensor. That is, we can also call as a error. Linearity is specified in terms of percentage of non-linearity. Okay, non-linearity percentage is equal to maximum deviation in the input divided by maximum full scale output. Okay, this is the maximum deviation. So divide by maximum full scale input, that is non-linearity. Next, hysteresis. The hysteresis is an error of a sensor which is defined as the maximum difference in input, maximum difference in output at the any measurement value within the sensor's specified range when approaching the point first with increasing and then with decreasing the input parameter. Okay. Next, resolution. So resolution is the smallest detectable increment change. Resolution is smallest detectable increment change of input parameter that can be detected in the output signal. Okay, I think you understand. Okay, stability. So stability is the ability of a sensor device to give same output when used to measure a constant input over a period of time. That is stability. So then deadband or deadband time. The deadband or deadband space of a transducer is the range of input values for transducer is the range of input values for which there is no output. Okay, so the range of input values for which there is no output. Okay, the dead time of a sensor device, the time duration from the application of input until the output begins to respond or change. Output begins to respond or change. This is the dead time period. Next one, repeatability. It is specify the ability of sensor to give same output for repeated applications of same input values. It is usually expressed as a percentage of the full scale range output. It is usually expressed as a percentage of the full range output. Okay, that means repeatability is equal to maximum minus minimum values given. repeatability is equal to maximum minus minimum values given into 100 divided by full range. Maximum minus minimum values given into 100 divided by full range. That is repeatability. Okay. So response time. So response time describes the speed of change in the output. Response time describes the speed of change in the output on a step-by change of the measurement. Response time describes the speed of change in the output on a step-by change of measurement. It is always specified within an indication of input step and the output range for which the response time is defined. That is response time. Okay. Then we'll the classification of sensor. So what are the sensors available? Okay. For displacement measurement, displacement, position, and proximity sensors are potentiometer, strain gauge, capacitive, differential transformers, optical encoders, pneumatic sensor, Hall effect sensors are example for displacement, position, or proximity sensor. Then if we want to find velocity and motion, we need to use incremental encoder, tacho generator, pyroelectric sensors like that, velocity and motion. Next, force, strain gauge, load cell. Example for identification of calculation of force means that is we are using strain gauge, load cell. Then for fluid pressure we are using diaphragm pressure gauge, capsule bellows pressure tubes, piezoelectric sensor, tactile sensor. Then liquid flow. For liquid flow using turbine meter, liquid level, floats and differential pressure we are using. For temperature we are using bimetallic steps, resistant temperature, thermistor, thermocouples like that, thermodiodes like that we are using for measuring the temperature. Okay, this is the common types of classification of sensors. Okay, in this chapter we discussed static and dynamic characteristics of sensors and what is sensors and transducers and the types of sensors available in the market or in the used in the manufacturing unit. Okay, thank you. We'll see in the next class.